Amazon DynamoDB's BatchGetItem functionality allows you to retrieve multiple items from one or more DynamoDB tables using a single API call. This feature is useful when you need to retrieve multiple items with known primary keys, as it reduces the round trips to the database and optimizes performance. In this video, let's learn how to get started using the DynamoDB BatchGetItem when building .NET applications. We will see how to use this using the high-level API and also the low-level API provided in the .NET DynamoDB SDK. Hello everyone, welcome back to this YouTube channel. If you're new here, my name is Rahul and I make videos around .NET. This video is sponsored by AWS and is part of my .NET on AWS series. DynamoDB BatchGetItem returns the attributes of one or more items from one or more tables. You need the primary keys of the items to use DynamoDB BatchGetItem. So you can get specific individual items using these functionalities. A single operation can retrieve up to 16 MB of data, which can contain as many as 100 items. If either of these criteria is violated, a partial result is returned, and the operation returns a value for the unprocessed keys. We will see this later in this video. To see the DynamoDB BatchGetItem in action, let's switch over to Rider. Here, I have an existing solution open, which is an ASP.NET Core Web API application. I started building this application when starting with the different ways of querying DynamoDB. I also use this in multiple other videos where I show the different functionalities of DynamoDB. This has the weather forecast controller and it has a bunch of weather forecast DTO items. If you navigate into the weather forecast controller, you can see different API endpoint methods that shows different querying capabilities and also ways you can interact with DynamoDB to insert or delete data. To see how the BatchGetItem works, we will add a new method in here. So let's scroll down. Let's go right to the end of the HTTP GET and where the first HTTP POST method starts. So let's add a new method under here. So let's give this as public async, return a task of list of weather forecast items, and let's call this getBatch. Now in this case, we need to have multiple known primary keys to retrieve the items. Now when building applications, you might come across different scenarios where you need to retrieve the items from the same table or even from across different tables. This could be when you're doing batch operations on the table, or it could even be a functionality in your UI where users are interacting with data in such a manner. Now, given that case, you'll need to specify multiple keys. Now, this could be coming through an API, or it could be even in a background process that does some work in the background. Now, since I'm using an API and I need to show passing in multiple keys, I'm going to make this as a post method so that I can post multiple keys via the body. So I'll keep the type as a dictionary of string so that I can take in different keys. Now, since the weather forecast item has the key of city name and the date, let's keep the dictionary as string and a datetime object. So I can pass multiple key value pairs, which will be the primary keys for this table. So let's call this as keys and let's create the new method. So in this case, since this is going to be taking in a dictionary, I'll need to keep this as an HTTP post method. So let's call this getBatch DynamoDBContext because I will be using the DynamoDBContext and we will be getting data from one table. So let's keep it that explicit name. Now, once we have the keys, we can use the DynamoDBContext to construct the batch query object. So let's look at the DynamoDBContext object and let's use the CreateMultiBatchGet function. Now, this takes in a type, which is going to be the type of the object that we are going to query. So let's specify weather forecast. Now we saw in an earlier video how the conventions in .NET are used when we use DynamoDBContext to determine the table name. Now in this case, since the weather forecast object does not have any attributes on it, it is going to use the name of this type to determine the table name. So in this case, it will be weather forecast. You can check that video in detail, which will be linked here and also in the descriptions below. Let's get back the response from this function as a batch get object. Now, once we have the batch get object, we can call the add key function on it and pass in the whole weather forecast object or a hash key or the combination of hash key and a range key. Now, in this case, since all we have is the hash key and the range key combination, let's pass that in to the batch get object. So now since we have this as a dictionary, let's loop through the dictionary items. So let's call for each. Inside the collection of keys, let's iterate each item as a batch key. So let's remove this braces, and we have the BatchGet.addKey and pass in the key.key, which will be the string that is going to be the city name. And let's also pass in the key.value, which is going to be a date type. Now, once we have populated the BatchGet object with all the keys required to be fetched, we can call the BatchGet.executeAsync method, which will execute this batch request. Now, since this is an asynchronous method, let's add in the await. Now, in this case, the response of executeAsync is simply a task. So we don't get the response of the results from this method. However, the BatchGet itself has the response for this. Now, if you look at the BatchGet.results, you can see the list of weather forecast in this case. So let's return the BatchGet of returns in this specific case. So let's put a breakpoint here and see this in action. So let's debug. Now this is automatically wired to launch Swagger, which shows the UI and the API endpoints in this application. So if I scroll down, you can see the new post method, which is going to be the weather forecast get batch DynamoDBContext one table. So let's expand that. Let's specify try it out, and let's pass in some city names and date inside here. So let's switch over to Amazon DynamoDB console, and let's go to the weather forecast table under DynamoDB. Now here we can go to explore table items and click run under the scan operation. So this is going to do a scan operation on the table and return the first records, which is returning the first 50 records. So let's copy this date and let's say Mumbai, and let's come back to Swagger and let's pass in the city name and the date that we just copied. So I'm using Windows B to open the clipboard manager and paste that in here. Let's also copy a couple of other dates. So let's say this one and the Brisbane date, and let's come back and let's modify this as well. Let's also populate one more item from a city. Now, since this is a dictionary item, I cannot reuse the same city name, but you can use a different data structure if that is the case. So let's come back and let's copy another item from here. So we have a string 5. So let's copy that and also a date from that. So let's paste in the date and also the city name, which is string 5 in this case. And let's click execute. Now this is going to hit the breakpoint. Now we have the keys as count 3, which gets all the data that we just passed in. So let's step through this. It creates the BatchGet object. It iterates through the keys and adds in the add key and value to this object. And once that is done, it executes the BatchGet. And once that is completed, we get back all the results in a single call. So let's continue the execution. And if we come back and scroll down in the API, we can see all the data that's returned back from DynamoDB. Now we have got the data for all these 3 items in a single batch. Now in this particular case, this was querying only one table. Now you can pass in as many items as you want, as long as it stays within the limit that we saw earlier, which is 100 items or less than 16 megabytes. There might be also scenarios where you need to fetch data from multiple different tables in DynamoDB. BatchGet also supports this. So let's see how we can do that by creating a new API endpoint. So let's come back to our application. Let's stop this. Let's copy this method. So let's copy that and let's create a new method under that. And let's call this as multiple table. So let's say get batch and call this as multiple table as well. Now, this is going to be exactly the same. So as we get the keys, we can create the BatchGet, iterate through it, and add the keys into the BatchGet request. Now, let's say I need to look for the same keys in a different table as well. Now, in your case, it might be a completely different object, and it could also be a different set of keys that you get in as part of your application code. But to keep things simple, I'll just reuse the same keys and fetch from multiple different weather forecast tables. So let's rename this as BatchGet1 and let's apply that rename refactoring. Let's now create a duplicate of this and call this as BatchGet2. And in this case, I'm going to use the type weather forecast table. Now this is automatically going to look at the table weather forecast table. Now instead of just looping it and adding to one of these sets, let's create a bracket and let's add it to both of the BatchGet request. Now in this case, I'm going to specify BatchGet2 and add the key to that as well. So let's specify key.key and key.value in this case. Now once we have the 2 BatchGets created, instead of directly calling the BatchGet1 execute async and BatchGet2 execute async, which is going to be 2 separate calls, let's comment this out. Let's specify a var batches and we can combine these two batch. So let's say batchget1.combine and specify batchget2. Now this combines these two batch requests into a single request. Now once we have the batches, we can specify the batches.execute async. So I'll have to wait on that and then get the data from the individual request. So to return the data, let's return this as two different items. So for now, let me simply return this as an object. And let's return this as return new. Let's specify weather forecast. That is going to be batchget1.results. And let's say weather forecast table, which is going to be batchget2.results. Now in your API or wherever you are using this, you could return back the results in a format that is more appropriate for your API or the application. Let's put a breakpoint here and let's run this to see this in action. So it launches another instance of the Swagger UI. So let's come back and copy this data and let's close this and scroll down and go to the new method that we just created. So let's say try it out. Let's paste this in here. Let's also go to the DynamoDB. Let's go to the weather forecast table and let's pick up another date that is there in that particular table as well. So let's copy Brisbane. Let's copy this date and let's specify that in here. And let's click execute. Now this hits the breakpoint as expected. So it first creates two batch get requests. It iterates through all the keys that we have passed in and it adds to both the batch get. Now in your application, this might be slightly different based on your use case and scenario, but I hope you get the idea. So once we create the different batch get requests on multiple tables, you can combine them into a single batch and execute that. Once that is done, we get back the results based on the data that's available for those keys. Now in this particular case, only two items belongs to the first table and the other one is from the third table. So you can scroll down and you can see where the forecast table has just one item. And if you scroll up, you can see the other one has two items. Now, if I was to create a new item with the same date and item in weather forecast table, so let's go to the post method in here, which looks at the weather forecast table, try it out. Let's specify Brisbane and let's also specify that new date that we copied from weather forecast table item. And let's create a new item in this. So let's keep this temperature as 50 just so that we can recognize that item when we fetch this back. So once I've executed, let's scroll back and let's fetch this execute request again. Now in this case, we're going to get back the new item that we've just created inside the weather forecast table. So you can see here Brisbane, which returns the item with the temperature 50. Now you can also see it returns the weather forecast table and returns the item from there as well, and which says 5 degrees Celsius. Instead of using the combine method, you can also use the method on DynamoDBContext, which is the CreateMultiTableBatchGet. This method takes in a params of batches that you can pass in, which it will combine and return you a multi-table batch get. So instead of using the combine function on the batches separately, you can pass the batchget1, batchget2 as a params property. Now this is going to return the exact same object. So let's say var batches, and you can use this to make the execute async. So in this case, we don't need to combine anymore, but you can use the create multi-table batch get. Both of these provide the same functionality. So let's put a breakpoint and run this again to see this in action. Let's come back to the same Swagger and click execute. It hits the breakpoint as expected. So it creates the batch get request and then it uses the create multi-table batch get functionality to combine these batches together and make that into a single batch. Now once we have the batch, it calls the execute async and returns the result as expected. So if we come back to the UI, you can see the results as before. So you can use either the combine function or the create multi-table batch get function to query across multiple tables. Now in both these cases, we use the DynamoDBContext, which is the high-level API from the .NET SDK to perform the batch get operation. Now in these cases, we do not get back the information on the exceeding of item count or even the size limits. The batch get object has only the results property inside that. Now to get the unprocessed items and the functionalities associated with that, we will need to switch down to the lower level API. So let's see this in action. So let's copy this first method again and let's paste this below the second method of multiple table. And let's call this as DynamoDBClient one table. So let's say get batch and call this as DynamoDBClient. Now in this case, we're going to use the DynamoDBClient instead of the DynamoDBContext, which is the lower level API. So let's remove this code and let's specify the DynamoDBClient and use the BatchGetItem async method. Now this takes in multiple parameters. Let's use the BatchGetItem request. So let's create a new object. So let's say BatchGetItem request, and let's create a new object of the BatchGetItem request type. We can pass this in as part of this method, which is going to also respond with the BatchGetItem response. Let's make sure to add an await in here because this is an asynchronous call. Now, if you look at the response, you can see this has the unprocessed keys properties which will indicate the keys that have not been processed as part of this batch operation. Now let's complete the request by passing in the request items as part of the request object. Now this is going to take in a new dictionary of string and keys and attributes object. So let's create a new instance of this and let's create a dictionary. Now the dictionary's key is going to be the table name that it's going to query. So let's specify the table name as name of, and let's specify weather forecast. We also need to pass the keys and attributes. So let's create a new instance of that. So let's create and specify the properties inside that. In here, we can specify the keys, which is going to be the keys that we need to query. Now this again is going to be a list of dictionary of string and attribute value pairs. So if you have multiple keys, you're going to create multiple dictionary items. The dictionary in turn will have the hash key and the range key as its dictionary values. So let's use the keys object and create a list of dictionary. So let's specify select and let's create a new dictionary. So let's specify new dictionary, string and attribute value objects. So in this case, the weather forecast has two keys, which is the hash and the range key. So let's specify the first object as the name of, and let's specify weather forecast dot city name, which is going to have the value of key.key, which is in the dictionary object. And let's also create a new entry, which is for the date object, and that is going to be the key.value. Now, since this needs to be an attribute value, let's create a new instance of new attribute value and pass in the key. So let's specify the key, and let's also specify the new attribute value for this date. Now, since this is a date, I'll need to convert this as a toString. And let's use the AWS SDK utils.date format as the ISO 8601 date format. Now, since this needs to be a list, let's convert this whole select statement to be a list object. So once that is done, this compiles successfully. So all we have done is loop through our items and set up the mapping for the weather forecast table, and we have created the keys and attributes and specified the different keys inside there. Now each keys is again a dictionary under that, which is going to be a string attribute value. So this has multiple sets of keys that points to different items in this specific table. So once that is done, let's execute the BatchGetItem request and get back the response. Now if you look into the response object, you can see the response has responses. This again is a type of dictionary of string, and it further has a list of objects. Now the first string represents the table name that you're querying and all the items that's returned from that specific table name. So if you have multiple table names, you will have multiple items in here. So let's flatten out the responses using the select many so that we can go through each of these items in the dictionary. So let's specify t to say the table, and let's say t.value, which is going to be the dictionary item. And from here, we can use the select statement and use the same document.fromAttribute map to convert this into a C# type. So we can pass this object inside here. And let's also call select and the DynamoDBContext.fromDocument and specify the type that we want to convert this to, which is going to be weather forecast object. Now, once we have all of this, let's call the toList so that we can convert this as a list object. Now, we don't want to invoke this, but just pass this as a func. I have shown this in different videos before, when using the DynamoDB lower level client. I highly recommend checking out the DynamoDB querying video to understand what is happening in detail in these statements. At a high level, all we are doing is converting these string attribute values into a dotnet type using a couple of methods from the DynamoDB SDK. So once we've converted this using the toList, we can return this as our response for this API. So let's put a breakpoint and see this in action. So let's come back to the old Swagger and copy this request. And let's come to the new API UI and look at the DynamoDB client and try it out and paste in the keys. Now if I click execute, it's going to hit the breakpoint as expected. Now this is going to create the request. Now since we are specifying only one table name, it is going to loop through and create the request for that. If we expand the request object, you can look at the request items and see the values that is getting passed in here. So this has the weather forecast key and the key attributes inside that. Now which has 3 sets of keys, which is going to be a key value pair for each of the items that we have. So we have the date value, date and city name combination for each of these as a dictionary of attribute values. So let's continue this request and it responds back. And here we have the responses, which has one count that is going to be against the weather forecast table. And it has a list of results inside that, which has all the properties from these objects. Now let's continue the execution and come back to the Swagger UI. And here you can see all the data that's retrieved using the lower level API. Now, one thing that the lower level API provides is also the additional information about the response. So if we expand this, you can see the unprocessed keys, in this case, which is 0, because it responded back with all the items that we requested it for. Now, if you request for more than 100 items, or if you exceed the data limit, then you will get an unprocessed keys. In that case, you can make an additional call to DynamoDB and process just the unprocessed keys. Now, in case you want to query multiple tables, all you need to do is repeat this particular section and specify the text name of. So as an example, let's copy this item and let's paste this in here. And instead of specifying one table, let's specify multi and let's rename the function as multi. Now, in this case, instead of just specifying one key value pair, you can copy this and replicate this using the next table. So in this case, we can specify weather forecast table and it will add another query request for these keys. However, once you get back the responses, if the objects are different, you will need to map them accordingly. Now in this case, since both of these items has same properties, I will be okay to map them to the same item. I can also use a different DTO item to map the objects from both these tables into the same object. And when you hit the operation limits using the DynamoDB batch item because you've exceeded the 16 MB or the 100 items, you can use certain techniques to retry and fetch the full data. There is some guidelines about this in the Amazon documentation, which I will be linking in the descriptions below. I hope this helps you to understand more about how BatchGetItem works in DynamoDB and how to use this when building your .NET applications. We saw the different ways you can get items in a batch using the high-level API and also the low-level API. One thing to keep in mind is you can query different tables if you need to. So based on your application and the scenario that you're trying to get data from DynamoDB, you can query one or multiple tables at the same time. This reduces the round-trip cost and also gets all the items in a single request. If you like this video, please make sure to hit the like button. If you want to be notified of future such videos, please hit the subscribe button. It also helps me to grow this YouTube channel. Thank you and see you soon in the next video.